All right, in 4.5a, we're going to talk about what's known as the general multiplication rule of probability. Suppose that A and B are two events resulting from the same chance process. We can find the probability of A or B with the general addition rule, which is what we talked about before. Remember, you add a probability of A, probability of B, and you subtract the overlap where it's both. But how do we find the probability that both events happen? This part right here. This piece of the puzzle. What if they don't tell us that? How do we find this out? Well, we use the general multiplication rule. For any chance process, the probability that events A and B both occur can be found using the general multiplication rule. And it says this: probability of A and B happening is probability of A by itself times the probability of B given that A has happened. All right? So let's look at this. Where did this come from? So the general multiplication rule says that for two events to occur, first one must occur. Then the given first event has occurred, the second one has to occur. To confirm that this result is correct, we start with the conditional probability formula. And this is what we did in a previous video. Hopefully it looks familiar. Okay? Now, what we want is this piece right here. So we're going to use a little bit of algebra to solve for it. So just like you would do in algebra, to get rid of the fraction on the right side here, we have multiplied both sides by the denominator. When I do that, what's left is what I have down here. Probability of A times the probability of B given A. And this leaves me what I wanted. Okay, so it's just taking a formula we already used and rearranging it. So let's try this out. Illegal music downloading has become a big problem. 29% of internet users downloaded music files. 67% of downloaders said they don't care if music is copyrighted. Find the probability that a randomly selected internet user downloads music and doesn't care if it's copyrighted. Okay, so you're going to have to decipher some things here. What would we want to find? Probably that a randomly selected music user downloads music and doesn't care. So I put that in notation here. Probably music and doesn't download. So the formula says I need to know the probability they download music and then the probability that they don't care given that they download music. So let's go back. This 29% is internet users who download music. So that's what I did here. I made my notation. The 67% of the downloaders, that's the given part, say they don't care about music being copyrighted. That's this. So mathematically, all I have to do is multiply these two guys together. All right? And it's really that simple. So when I do that, I get 0.194, and there's my answer. It's done. Example 2. According to Forrest Gump, life is like a box of chocolates. You never know what you're going to get. Suppose a candy maker offers a special Gump box with 20 chocolate candies that look alike. In fact, 14 of the candies have soft centers and 6 of them have hard centers. Choose 2 candies from the Gump box at random. Find the probability that both candies have soft centers. So all I've done here is write out what they told us. The probability of getting a soft-centered candy is 14 out of 20 for that first candy you choose. Probability of getting a hard center is 6 out of 20. Now, this one works out just a little different because I've got 2 candies, right? 1, 2. Okay, if I want the first one to be soft-centered and the second one to be soft-centered, let's think. Here's the probability of the first one being soft-centered. There's 14 out of 20, right? Now for the second one, I have to think about the fact that I've already taken one piece out of the box. So there's no longer 20 pieces in the box, and there's 19 now. And if I did what I wanted, there were 14 soft centers, and I chose one, then there's now only 13 soft centers. So I multiply these two guys together. So be careful when you multiply fractions. Remember, you have to multiply top to top, bottom to bottom. And when you get it in your calculator, you get 0.479. All right, so you're going to have to read your questions very carefully for all the clues that they give you in the problem to be able to get your probability set up correctly.